All right, so we are going to go over 3.1. So this is a continuation on to yesterday. Yesterday, we solved systems by graphing. When I say systems, I mean two lines. So we solved where do the two lines intersect, and we want to know that intersection point. Now, sometimes it's hard to do that with graphing, whether the points are in between, like -1 and -2. They're in between, so they're not perfect. Does that make sense? So we have these two other ways. They're non-graphing ways to do this, right? So we have our steps for substitution, the first method, substitution. And our steps are, first one, pick an equation and solve for y equals or x equals. It does not matter. It's up to you. I prefer just y equals because we're used to that. 2 is substitute the other side of y equals in for y in the other equation. So we'll show you what I mean by that. 3, solve for the other variable. 4, if need be, plug the answer from number 3 into each equation and solve for the other variable. Your final solution should be an ordered pair, right? Because our goal always is to find the intersection point, and that's an ordered pair in x comma y. So this first thing right now, I'm going to take this equation and I'm going to solve for y. So I'm going to add 5x on both sides. So you get y equals 5x minus 2. And then I have my other one. So there's number 1, and here's my second equation. I don't have to do anything for the second equation because it just says pick any equation and solve for y equals. All right? So here's step 1. Now step 2 says substitute the other side of y equals in for y in the other equation. So that's this 5x minus 2. That is being substituted in for y here. So we have negative 3x plus 6 times 5x minus 2 equals negative 12. So this was step 1. Here's step 2. All right, so I'm just going to number the steps for you. All right, so now we are going to solve for x. Solve for x. This is just solving an equation like we've done before. I want to distribute right here. So I had negative 3x plus 30x, right? 6 times 5 is 30x. 6 times negative 2 is negative 12 equals negative 12. All right. So now what I'm going to do is I'm going to combine my x's because they're like terms. So I get 27x minus 12 equals negative 12. I'm going to add 12 over. Add 12 over, so I get 27x equals 0. Right, negative 12 plus 12 is 0. Then divide by 27, and I get x equals 0. All right, so now I have my x. All right, this was 3. Doing all that work was number 3. 4 says if need be, plug the answer from number 3 into either equation and solve for the other variable. So we have an x, we need a y. So I'm just going to use this one right here. It doesn't matter, I can use this one or that one. So I go y equals 5x minus 2. So this is step number 4. I'm going to plug y equals 5 times 0 minus 2. Right, our x was 0. So y equals 5 times 0. 0 minus 2 equals, so y equals negative 2. So where do these two lines intersect? It's at 0 comma negative 2. This is our final answer. All right, so take a second. We'll look at that a bit. All right, if you would graph these two, yes, your intersection point would be at 0 comma negative 2. All right. This example is a lot like it, right? We would just add 5x over, so I'm going to give you one that looks a little bit different. Right below it is the negative 5x minus 3y equals 23. Now this is going to have some fractions involved, but you have to choose which one am I going to choose first. Which one am I going to? I don't have to use this first equation as the one that I solve for y. I can notice that the second one would be very easy to solve for y here. So that's what I'm going to do. So I'm going to subtract 2x on both sides, and I get y equals minus 2x plus 7. All right? So again, this was step 1. Pick an equation and solve for y equals, or x equals. Now step 2, we're going to substitute this negative 2x plus 7 in for the other equation. So part 2, we have negative 5x minus 3y equals 23. I'm going to substitute this part in, so I have negative 5x minus 3. Instead of y, we have negative 2x plus 7 equals 23. Just like that. Again, I need to distribute this negative 3. So I have negative 5x plus 6x minus 21 equals 23. I can combine like terms here. So I get x minus 21 equals 23. I lied about the fractions. And I add 21 on both sides. I get x equals 44. All right, this is a great example of why this would suck to graph, because you'd have to go all the way out to 44. Okay, so then you can do this in algebraic way. X equals 44. We can plug this back into one of the equations. It does not matter, again, which one we do. So this was part 3. And then 4 is plugging back in. So I'm going to go y equals, well, actually, I'm going to show it with the original. So we're going to do 2x plus y equals 7. X we said was 44. So we have 2 times 44 plus y equals 7. 88 plus y equals 7. Subtract 88 on both sides. And I get y equals 7 minus 88 is a negative 81. All right. So again, my final answer is 44 comma negative 81. Take a look at that for right now. Just catch up if you need to. Notice if you would just plug 44 into here, you get negative 2 times 44 is negative 88, plus 7 is negative 81. And you would see the same effect here. All right. Again, just a reminder from yesterday, if you get 2 parallel lines, it's no solution. If you get the same line, it's infinite solutions. Good? All right, so flip the page then. This is the second method, elimination. It's a little bit different how it works. There's different steps. So first part of elimination, we need to multiply one or both equations by a number to result in 2 equations that contain opposite terms. Okay, I'll explain what that means in a little bit. To add the equations, eliminating one of the variables. So you have to decide which variable are you going to try to get rid of first. Then solve the equation and substitute to solve for the other variable. All right, so we're going to show you the first example first. So the first example is really straightforward. There's not much that you have to do with it. Actually, I think all of these are like that. 1 second. Yeah. So I'll give you an example, then we're going to have to change this example around real quick. But this first example, we have negative 4x minus 2y equals negative 12. And then 4x plus 8y equals negative 24. First thing you have to look at is, do I have to multiply any of these by to get rid of a term? Because we're going to add down. All right, we're going to add the equations down. Do I have one that's like a negative 2 and a positive 2 for both x's? Yes. Notice our x's, we have negative 4x, and we have 4x underneath it. So when I take negative 4x plus 4x, these are going to cancel out to be a 0x. Negative 2y plus 8y is 6y. Negative 12 plus negative 24 is negative 36. I divide by 6 on both sides. I'm solving for y now, and I get y equals negative 6. Once I have my y, I can go get my x. All right, so this is basically, this was part 2 and 3. Steps 2 and 3 were this. 4 now is substituting to solve for the other variable. So I have negative 4x minus 2y equals negative 12. I'm going to substitute in for y. So I got negative 4x minus 2 times negative 6 equals negative 12. We get negative 4x plus 12 equals negative 12. Subtract 12 on both sides. Get negative 4x equals negative 24. I divide by negative 4, and I get x equals 6. So my final answer then, is 6 comma negative 6. X's go first, and then the y, 6 comma negative 6. Questions there? I don't know why I just asked for questions. Good. So the last one now, I'm going to change it around a little bit. We're going to get rid of this 4. This 4 is gone now. Good. So the 4 is gone from that equation. So you have x plus 8y equals 20 and negative 4x plus 2y equals negative 30. This is where I want to talk about you have to decide which variable do you want to get rid of. It does not matter. You either have to decide you want to get rid of x's or get rid of y's. If you choose x's, then you have to figure out what are you going to multiply this entire row by in order to get a positive 4x, right? You have to have opposite terms. So if we have a negative 4x, we need a positive 4x here. If we're going to get rid of the y's, notice we have an 8y and a 2y. I can multiply this bottom one by negative 4. That would give me negative 8y. All right, so let's do that. So I'm going to multiply the bottom one by negative 4, not negative 8, sorry, negative 4. All right, so now I'm just going to rewrite everything over here. So we have x plus 8y equals 20. We didn't do anything to that part. This is kind of like your step 1, the multiply one or both equations. So we get x plus 8y equals 20. Remember that 4 in the beginning here doesn't even matter anymore. It's not even a part of the example. So we have negative 4 times negative 4x is 16x. Negative 4 times positive 2y is negative 8y. Negative 4 times negative 30 is 120. This is where I'm going to add down now. This is our step 2. So I get 17x plus 0y equals 140. So really that's just 17x equals 140. Divide by 17, and I get x equals 140 divided by 17, 8.24. I rounded, so really it was like 8.235. So I rounded to 8.24. That's our x value. Now you need to plug x back in. Pick an equation. So here's step 3. Step 4 I'm going to put right here. And I'm going to choose the first equation, x plus 8y equals 20. I'm going to plug x in, so I have 8.24 plus 8y equals 20. So 20 minus 8.24, because that's going to be my next move. I subtract 8.24 on both sides. I get 8y equals 11.76. Divide by 8, and I'm running out of room. And I get 1 point, put it right here, y equals 1.47. Again, our final answer then is 8.24 comma 1.47. That's where these two lines, x plus 8y equals 20 and negative 4x plus 2y equals negative 30, will intersect. This is a little bit more of a difficult, more complex example, right? The first one's a little bit more easier to get. All right, that is day 2 of 3.1. Your homework again is on the homework log. It's number 2.